Everybody hear me? Yeah, thanks for coming in. I hope my panic isn't too obvious. I do have a little bit of a stutter, which my colleagues might actually not know. So forgive me if I'm looking at my script too much. Yeah, today I'm going to be talking about our experiences converting games to Unity's universal render pipeline, how that helped us get our projects done and running well, and of course getting them shipped. I want to put into perspective the value of the URP and why I never trusted the naysayers, especially from the beginning, and that I don't bore you too much talking about frame times and cameras. A little history of me, just so you know where I'm coming from. I've been in the Netherlands for nearly 7 years, working for Coglia, as Matthijs said, and then we were acquired by Behavior about 2 years ago. At Coglia, I worked on about a half a dozen games, doing ports, rebuilding game engines. And my first experience with Unity was a game called Corpse Party Blood Drive back in 2017, 2018. After that, I went from Unity project to Unity project before the Shadowrun trilogy hit our desks with Paradox Interactive. By the end of that project, we had Chaos Gate Demon Hunters, a Warhammer game. And during the Shadowrun trilogy, I'd moved up to a lead programmer position. And then just before we finished development on Chaos Gate, we were acquired by Behavior. A little info about Unity in case you're not aware of exactly what it is or the scope of it. It's one of the most popular game engines in the world. It varies year to year, but around 2021, 2022, 60% of developers were using Unity. That might have declined a little bit after the controversies a few years ago, but it still represents a huge chunk of the game development market, particularly among indie developers and the mobile space. On that note, Unity's put in a ton of work over the years to make sure that they support every platform, making it easy to go from PC to iOS, Android, to Switch, or whatever else is out there. On top of that, its accessibility has led to a lot of YouTube tutorials, forums, blog posts. A huge community has been built up around it. And up here, I've put in some examples of lots of successful games across genres, game mechanics, art directions. My personal favorite up there is V-Rising. Recent update has been very good, so check that one out. To the URP itself, what is it? For a long time, Unity had only one renderer. In 2018, they introduced a new package called Scriptable Render Pipeline, which lets programmers build custom renderers for the first time, with Unity covering fundamentals like clipping. They currently maintain two of their own renderers, HDRP and the Universal Render Pipeline. URP covers lower-end devices and scalability, and covers most games need, at least according to Unity, while the HDRP does, as the name implies, higher fidelity targets, more advanced, more expensive features. To this day, there still isn't full feature parity between the built-in renderer and the SRP renders, and some things they just said won't be added. One thing that they are missing, that'll come up later, is surface shaders, which lets you write shaders very easily, swapping out how they react to lights without affecting the whole game. And over the years, this has been cited as the main reason that people don't like the URP. They don't want to switch to SRP, URP packages. They are planning to replace this functionality soon with their block shaders, but right now it's still a giant pain to write simple shaders. The easiest way to do it without using the shader graph, which is something else that has a whole host of its own shenanigans, is to copy the default shader and modify it yourself, but that has a whole host of problems with files, referencing files, and you're 6 layers in and you have no idea how a pixel ends up on screen. We can see from this chart, from Unity themselves, that most games from 2023 are using one of the SRPs, with most of them on console using the URP, and about half on mobile. The biggest tool that they added to the SRP and the URP was the batcher, which takes the old method of batching objects by material and does it by shader. And this means a lot more objects can be batched and drawn at once, which we'll see later in the presentation is a critical change. Another tool that was very important to us is the batch render groups, which was introduced for Unity's ECS and later paves the way for their new resident drawer, which again will come up later. In the future, Unity is planning to combine the two into something they're calling the unified renderer. They're very clever in their names, which is something most developers I know are very excited for, at least the programmers. A huge benefit to me as a wannabe graphics programmer, was direct access to the render source so that we'd be able to make changes that suit the game that we're working on rather than what Unity thinks we should do. Now, this isn't an exhaustive feature list, but these are the things that really served us in the coming case studies. So that was a lot of info about Unity. So let's get to the actual games I want to talk about and go over what we did for them. Yeah. There were two games that I worked on where I made the decision to move us to the URP. Shadowrun, the Shadowrun trilogy, which was originally developed by Harebrained Schemes, and then a Warhammer 40k game called Chaos Gate Demon Hunters, developed by Complex Games. There are some similarities between the two. Both are turn-based tactics games. Both started development years before URP, so I don't blame them for not using them. And especially Shadowrun, I think they started development in 2011 or 2012. And importantly, both games were built in a way that switching to the URP wasn't impossible and could bring big benefits to do. I'm going to start with Shadowrun. The original game targeted mobile with its first two releases, Returns and Dragonfall, and then the last release, Hong Kong, only appeared on PC. So they took a lot of liberties on that one to do things, like use a lot more lights. One of the biggest things relevant to this talk was that about 2/3 of the way through development, Paradox offered us a special review from Unity themselves. They would send we would send them the source code, and an engineer at Unity would take a look and give us some advice on a whole host of issues. And we're going to focus on what they said about performance. And I've brought some numbers from running the game on the Switch, just before the switch to the URP. This is taken from the Heioi hub in Shadowrun Hong Kong, which was their heaviest scene, basically, across all three games. By the time we did the project review, we were doing optimizations across the whole game, but a big goal for us was to not compromise on any of the visual fidelity for the Switch compared to the other games. The original mobile releases of Shadowrun had significantly reduced fidelity in places like the fog of war and the crowd sizes, so we really wanted to avoid that, keep the game in parity. It ran mostly okay on Switch for Returns and Dragonfall, but Hong Kong had so many problem areas. We cut lights, we reduced frame time spikes, smoothed operations over frames, but we got to the point where the main bottleneck was just the rendering. So we were preparing to take drastic action by the time Unity got back to us. And that drastic action was to switch to the URP. Along with a lot of other advice, Unity recommended us switch to the URP. The batching would be significantly better. That was our main issue. We were at about 2,000 draw calls in most scenes, and we got that down to about 200. Heioi itself, our worst scene was 3,000 to 600. And then the lights in URP in general are just better, but more performance, so that helped a lot as well. But it wasn't all easy. Like I said before, there's no surface shaders in the URP, and guess what? All the shaders in Shadowrun were built with. Then when you take a camera, you can render it with an override shader, which lets you do fun things like X-ray vision and character highlights. And in fact, when we later went to do Chaos Gate, they did basically the same thing. So it's a pretty common method to achieve visual effects like that. And then importantly, when you use a override shader, you still keep the material data for every object. So then you can do things like you layer like a blue highlight, and then you can keep the character's internal layout of their textures. But there was no override shaders supported in URP at the time. I needed to build custom passes to add to each shader, which is a very manual process. Unity expects you to use shader graph to create lit shaders, but like I said earlier, they don't support a lot of things, and one of those things is custom passes. So I had to manually rewrite every shader, which I think in the end was about 100. A silver lining was that during that time I was condensing shaders that had no real reason to exist as separate shaders in the URP. And there were about 5 prop shaders, so every object in the game was called a prop, and there were about 5 shaders that they shared, and I got that down to 2, which again saved us a lot of time on the batching. So replacing the cameras with the custom passes saved us about 7 milliseconds just from camera overhead, and then we got about 66 milliseconds from the batcher. So overall, we went from about 80 milliseconds to around 15 at worst, which works out to about 8 FPS going up to 30. In retrospect, without going to the URP, I strongly doubt that we would have made the game run any better without taking a machete to it and getting it to run on the Switch. So I spent about 2 to 3 weeks working on this, just the main switchover. I think there was a couple of weeks of bug fixing after. But in my opinion, it was well worth the time. So that was Shadowrun. We moved straight from Shadowrun to Chaos Gate. So it was interesting to work on 2 turn-based games back-to-back, see how they did things differently. One is an RPG, of course, in Shadowrun, and Chaos Gate is more of an XCOM-like. But Chaos Gate presented a whole host of new challenges. It has a much more complicated visual style. It uses a deferred renderer, and they created a method for rendering a curved UI that still responds to input correctly. And that used 3 cameras to function, which was rough. On Chaos Gate, our lowest end platform was the PS4. We didn't target Switch for this one. And the numbers on the screen here are from their tutorial, which ended up being one of their heaviest scenes. So it was very convenient that it was right at the start. Off of Shadowrun, I was freshly aware of the URP and all of its pitfalls and its quirks. So when I was discussing with the original developers, I brought up the potential to move to the URP for performance, which they were actually very open to. I think they actually already investigated it themselves, and they were happy to let someone else do it. We were definitely glad to move to the URP after doing some profiling. Just like Shadowrun, they had a bunch of cameras to do things like highlights. Importantly, some of those cameras were also running their own separate post-processing, which the URP did not handle well. And a big difference was that they were using deferred lighting, which they were taking full advantage of to scatter over 100 lights per scene. So even after we switched to the URP, we were sitting at about 2,000 draw calls. Now, the biggest issue we had was the GPU memory. It could spike up to 5 gigabytes, which would just crash immediately on a PS4. For about 6 months, I think we were relying on the PS4 Pro just to get the thing running while we sorted out the memory problems. Yeah, like I said, it was a much more complicated process, and it took way longer. I think in the end, it was about 6 months of work on and off compared to the 2 or 3 weeks on Shadowrun. And a big part of that was just there was a huge number of shaders on top of their much longer gameplay cycle and more complex visual effects. Another issue was we were constantly having to wait for Unity to catch up with URP and what we needed. We had to upgrade Unity and the URP a bunch of times to get things like TAA and decals working. At one point, we updated from 2020 to 2021, and the URP had basically broken how cameras work. I don't know how that managed to ship, but we went straight to 2022 after that. So where I learned that living in the Unity tech stream is a very scary place to live. But to achieve the curved UI, the original game used 3 cameras, and we really wanted to reduce cameras as the overhead from them is quite significant. One of those challenges was that in order to get the post-processing to work with the multiple camera setup, I had to edit the Unity source to get the alpha channel to persist, because otherwise Unity just dumped it into the void. For what reason, I have no idea. Then, just like Shadowrun, I had to replace cameras with custom passes, which thankfully was much easier to do this time because they were using Amplify, which is a really good shader editor that actually predates Unity's built-in shader graph. Getting it to work with custom passes was a little fiddly, but it was at least possible, and it meant we cut a bunch of cameras from that. And then lastly, I'll talk about it more later, but the cameras constantly generated like 3 or 4 times as many render textures as we would expect. And it was so bad that I opened 2 different tickets with Unity support. And it took, I think, 3 months for them to finally give me an answer, which wasn't super helpful, seeing as I had to fix it myself anyway. But after all of that, we got the game from about 9 frames per second on the PS4, in the worst case, to about 34, which, funny enough, was about the same improvement range as we saw for Shadowrun, which I don't know if that's a coincidence or what, but it did come from, though, a lot of work, a lot more work on Chaos Gate, like I said, 2 to 3 weeks on Shadowrun versus 6 months on Chaos Gate. So, I was sitting in the audience at Unite 2023, and the speaker was talking about something they were calling the GPU resident drawer. And as they were describing how it worked and what it was for, I kept thinking to myself, this sounds very familiar. Wait a minute, we did that. So while we were optimizing Chaos Gate, one of my colleagues, Matthijs, found an API that had been released in 2022 for Unity Dots, which is another one of their big technology stacks. But it lets us take control of how objects are batched in the scene manually, and also requires us to manually cull them, which in our case was actually an advantage, and then uses their high-performance jobs to crunch through the numbers. And at the end, what we ended up building was effectively a primitive version of Unity's resident drawer. So I think we were knocking on the right door there in terms of performance. And at the end, it got us over the hump to get more than 30 FPS on a PlayStation 4, which I could call done. So here we have the name of the talk. I want to talk about the cameras and the issue of camera GPU memory in particular, which I spent months getting down on the PS4. So after removing all the cameras, optimizing game textures, LODs, shader variants, asset bundles, we still had problems with memory spikes crashing the PS4. And when I really dug into the render textures, I noticed a very strange pattern of behavior. I'm not sure how easy it is to see on the screen, but it was a lot of duplicate names in the frame debugger and the memory captures that I couldn't explain. This is actually taken from an empty 2022 project. It was a lot worse than the original game, but I don't have any screenshots from back then. But it illustrates the problem. In this example, there's over 100 megabytes of duplicates, which when you only have 2 gigabytes of VRAM on a PlayStation 4, or even less sometimes, that's a lot. Especially when you have to pack in LODs and character textures. Now, the reason this happens is a little technical, and I don't want to bore you too much, but it has to do with cameras swapping back and forth between the forward rendering for the UI and then the deferred rendering for the main game. And then when the URP switches, it disposes of the textures on the forward render, then allocates new ones for the deferred, disposes those to go back, and now you have multiple copies of the same texture. For those who don't know, an important thing about GPU memory is that you can dispose of textures all you want, but until the memory is flushed at the end of frame, those textures are still there, taking up memory. If you allocate a gigabyte of textures and then dispose of them, you've lost a gigabyte of memory for the whole frame. So reusing textures is critical. So what I did to solve that was to build a buffer that stored those disposed textures, and before creating new ones, check that buffer for any matching textures, and reuse them if they exist. And then at the end of frame, clear things up properly. Now, good news, Unity did exactly what I did for Unity 6. And I don't know if it's because of me that they fixed it, but I did report it to them twice in the Unity dev support, so I think I helped make Unity a little better. Although I think my solution was still better. Just a few quick examples of similar challenges we ran across on both projects. A big one that trips up a lot of people, actually, when they switch a game to the URP is that the built-in renderer uses a linear light fall-off, while the URP uses a more realistic inverse square fall-off. Now, if you've built your game with the former in mind, the switch basically makes your game too dark. And then when you try and raise the light intensity, your scene is still dark, and then you have bright burning suns as point lights. And it looks pretty bad. For both games, the solution was for me to go into the Unity package and modify the light code to match the built-in renderer. It'll never be perfect, but we got close enough that minor tweaks were all that was needed. Unity 6 actually added a document to discuss this issue, so that should help future devs as well. Although I did find it strange when I tried it myself, it didn't match. And in fact, my code was matching more closely, but take that up with Unity. The second and more troublesome issue is that the built-in renderer was very common, as I've mentioned in the presentation before, to use multiple cameras to achieve certain effects, like character silhouettes. But with URP, you're better off doing that with additional render passes or custom render features, as they call because every single URP camera has a lot more overhead tied to it than a single built-in camera. There's a lot more to talk about on the camera topic, but trust me, it's one thing to say replace the camera, and it's another thing to actually do it. So just one sentence, doesn't do justice. So to wrap up a bit, the URP has gone through a lot of major changes over the years since it was first introduced. In fact, it was originally called the lightweight render pipeline before Unity decided to make a less creative name. And there has been a lot of bumps along the way, like I said. But I now believe that the URP is mature enough and has been around for a while, long enough that if you're starting a new project, you should join the majority of projects coming out today and pick at least an SRP render, so maybe HDRP or write your own. There's definitely a learning curve, especially for people and studios that have a backlog of content and shaders and tooling for the built-in render. You have to do a real assessment on whether or not it's actually worth it to discard or rework all that. But it will set you up better as well when the unified renderer comes out, Unity 7 maybe, although they haven't made any guarantees on that. One thing I see online that I would caution against is treating the URP as lesser just because it doesn't have certain features that maybe the built-in does. If your game depends on something called the grab pass, which is something Unity has said that they will not reintroduce, then you're not gonna enjoy the URP. But the fact that it doesn't have that or any of the other features that's still missing, to me, doesn't make it worse. It just makes it different. And I hope the case studies that I've presented show that you can get serious performance improvements, at least by switching. But it's not a silver bullet. There's still a ton of work to do once you make the switch, especially in more complex, more visually complex games. Lastly on that, I want to say that it has kind of a bad reputation that I'm sure some of you have at least heard of, especially on parts of the community forums and on Reddit. And I've met a traumatized artist or two who's been haunted by the dreaded magenta material. And much of that reputation was deserved at some point, and some of those problems are still around today. But if you're reading forum posts from 3 or 5 years ago where people are bashing it because it doesn't do this, doesn't have that, I hope that I've given you at least some real-world evidence of games that actually came out with good reviews that have benefited immensely from Unity's universal render pipeline. And lastly, I want to thank 2 developers in particular. Alexander Dektyarov from Unity, he did the original report, and I had a good talk with him on the advice that led us to switch Shadowrun to the URP, and Frano Sailor from Complex Games. He went on the journey with me to switch Chaos Gate over to the URP. That was everything I wanted to share. There's actually a ton I left out, a lot of rage and pain getting things to work that I didn't have time to get to dig into, and a lot of it that maybe only the nerdiest of Unity programmers might care about. Like the nightmare that post-processing was getting Chaos Gate running. So feel free to ask me any questions you have in a moment. Trust me when I say if you want to come talk to me out on the conference floor, be prepared because I will happily bitch and moan about Unity. And then for any of my fellow programmers, there's some resources available from Unity that you might find helpful. And thank you all very much for listening.
We have time for 1 or 2 questions. There.
Oh, you're okay. Thank you. Well, first of all, thank you for the talk. Very insightful. My question is mainly about optimizations and when in the development process do you recommend doing it? So you can balance between predicting when a bottleneck would occur and optimize for it beforehand, but run the risk of over-optimizing, or do you recommend just waiting until the end, seeing where the bottlenecks are, and then optimizing them?
Yeah, it's a great and difficult question because the answer really is it's vibes-based. There's a lot of guesswork and a lot of mistakes to be made on that front. I personally am biased towards doing it early and often, making the correct decisions to make sure that your game runs well. And that's why I recommend the URP, actually, because it sets you up for success from the beginning, in my opinion. I think there's a lot you can do at the start, and I think maybe Shaun will talk about that in the next presentation, to set you up for success without too much cost. But there is definitely a lot of advantage to leaving things to the end and see where your game falls out. So I guess the answer is kind of whenever. But yeah, at the beginning and the end are the best times I find, because in the middle you're trying to finish your game. Yeah, and setting up pipelines in the beginning, for example, make sure your art assets are delivered correctly in the first place. You know, that the correct import settings, like a lot of the Unity ports that we've done, half of our memory savings have just been going in and setting the correct mesh import settings. Yeah, you know. We actually build tools that do it automatically. They go through and pull them back. We run the game, and as soon as it throws an error, it's like, okay, this one does actually require that setting. Like the making a mesh read-writable by default actually was a huge mistake in, I think, Unity 2018. Yeah, it was. I actually went back to Unity 2018 recently for a project, and I was like, what? No. So yeah, I hope that helped.
Yeah, I said we had time for a couple of questions, but I didn't know you were answering them this way. So,
Well, it's a very big question, yeah.
Yeah, a great question. Thank you. We have to wrap up for this presentation. Thank you so very much.